In most group discussions, the loudest voice wins. We've all been there. Someone takes the floor and never gives back. But what about the quieter ones? The thinkers, the people who need just a second longer to speak. That's the imbalance we wanted to challenge, not with an app, not with a timer, but with a physical prototype that reshapes how we take turns in conversation. Hi, I'm Hendrik. I study interaction design at the University of Queensland, and this is a prototype I designed with my team, a tangible system that brings fairness, randomness, and shared control into group discussion. Here's how it works. 3 people sit around a shared device. When everyone presses the sensor at the end of their tube, the system comes to life. A small bird on top rotates randomly to point at one of them. That person becomes the speaker. They get 30 seconds, and it's visible. A glowing LED stripe inside the tube begins to count down. But here's the twist. Time is flexible, and everyone plays a role. If you support the speaker's point, you shake the tube. They gain time. If you disagree, you pull the tube. They lose time. Even the speaker can subtract their own time if they finish early. Each adjustment has diminishing value, plus 8 seconds, then plus 4, then plus 2, until it reaches 0. It's not about fighting for time, it's about signaling attention. And to start or end the discussion, everyone must press their pressure sensor at the same time. Mutual agreement encoded in gesture. The hardware, 2 ESP32 microcontrollers at the core, 3 motion sensors for gestures, 3 pressure sensors at the tube ends, individually addressable LED stripes for countdown, and a stepper motor to rotate the bird pointer. Pressure sensors, LED stripes, and the stepper motor are connected to the main ESP32 board. Motion sensors are connected to the second ESP32 board, and then we connect 2 boards. The main one will get signal about the motion sensors from the second board. The code is fully modular, split into motion, pressure, LED, and core logic that made debugging fast and scaling future features easier. Talking about my role, I wrote the foundational code that runs the entire interaction. The random speaker selection, the time countdown engine, and the dynamic time adjustment logic, all from scratch. In the early stage, I mapped all interactions to button inputs for testing. I also used the slide potentiometer to simulate the LED countdown by manually fading brightness, giving us an early feel of time decay without sensor input. As our prototype evolved, I replaced these with gesture triggers from the motion sensors and pressure sensors to detect simultaneous agreement. I also structured the code into 4 clear modules for motion, pressure, LEDs, and main logic, which made debugging much faster and collaboration much easier. I handled all system integration and ensured that the LED countdowns, motor direction, and gesture readings were tightly synced and reliable. But this wasn't smooth sailing. The stepper motor is drift. It doesn't know where it ends up, so we had to slow it down, calibrate manually, and accept a little imperfection. The motion sensors, they're sensitive to wire length. Too long and they glitch. We had to move them closer to the microcontroller, sacrificing some detection accuracy. Still, through all of this, I learned more than I expected about hardware limits, I2C noise, timing loops, and how physical systems demand physical intuition. We've even added visual feedback, blue flashing when the system is initialized, green lights when participants are ready, though we're still exploring how to signal ready to end without interrupting the countdown display. And the bird, it's not just decorative. It was inspired by old European weather vanes, the ones that spin to show which way the wind blows. We thought, what if your conversations followed a similar logic? A playful, symbolic pointer for a serious goal, fairness. If I were to continue this project, I'd bring in wireless noise cancelling headsets for a more immersive experience, a more precise rotation mechanism, and a better way to calibrate default speaking time based on real conversations, not just assumptions. This wasn't just a technical challenge, it was a question. How can we design for people who are rarely heard? Not just make space, but build systems that protect that space. Thanks for listening. This is one of my favorite things I've built.